Okay, here's Jane, 3 miles offshore, and there's this village down here 8 miles from the nearest point on the shore. So we've got a right triangle right here. She's going to swim to some point P at 2 miles per hour, then walk the rest of the way instead of running, I guess. And we want to know how far down the shoreline should she row to create the minimum time. Okay, and this diagram illustrates the point that she should row to, 1.309 miles downstream. Here's another diagram where this distance is 4.8. So the idea is that this right triangle right here, if we use the Pythagorean theorem, we can get this distance is the square root of x squared plus 9. Since distance equals rate times time, the time will equal distance divided by rate, and she's running or rowing at 2 miles per hour. So this is an expression for this amount of time, and then this distance is 8 minus x, and the time is 1/5 of that. So here's a function that represents the total time it takes Jane to row. And if we take the derivative of that function, set it equal to 0, we'll have our critical numbers. We can test the critical numbers using the first or second derivative test. I'd recommend the first derivative test in this case. Here's the derivative. Hopefully you can follow along there. I use the chain rule here. Simplified, set the derivative equal to 0. Cross multiplied to clear the equation of fractions, squared both sides, and then solve for x. And this is what we get, x square root of 21 over 7. Actually, if we solve the equation, we get plus or minus that. We can reject that, the minus solution, for two reasons. First of all, it doesn't satisfy this equation. And second of all, we're not talking about a negative distance. Okay, so here's another diagram where this red dashed line is actually the graph of the first derivative. I'm sorry, it's a graph of the t of x, and this green dashed line is a graph of the first derivative of that function. You can see to the left of 1.309, the first derivative is negative, which means the original function is decreasing. To the right of that critical number, the first derivative is increasing. That means we have a relative minimum here. And you can see that there's where the first derivative is. There's the y value. The time that it takes her to row is to row and then to walk, if we move to this point, is 2.97 minutes. Any other value of x, including this one, gives a greater value than that. Okay, there you go. Hope that helped. If you have any questions, post a comment.